we have to obtain the node voltage equations for the circuit in the following figure. Alright, so the node voltage equations, we have to find the equations for these. Okay? So let's start by writing some directions of current. So this is the ground node, so it'll be 0 volts. So this is I1, this is I2, this is I3. Hold on, let me draw this better. Okay, this is I4, and this is I5. So let's start by writing the equations for node V1. Okay, so all the equations for this node. So we see I1 and I2 are leaving the node, and I3 is entering the node. So that's the equation for V1. For the equation for node V2, we see 2 amps and 1 amp is entering the node, and I2 is also entering the node. Alright, so this is just 3 plus I2 equals 0. For node V3, we see I3 and 1 amp leaving the node, and I4 is entering the node. And for node V4, we see I4 and I5 are leaving the node, and 3 amps is entering the node. So now what we're going to do is find a formula to substitute these I values in. So let's find the formula for I1. So I1, we see it goes from a high potential to a low potential. So V1 minus 0. And it goes over the 10 ohm resistor. So it'll just be V1 minus 0 over 10, or just V1 over 10. For I2, we see it goes from V1 to V2 all over 5. For I3, we see it goes from V3 to V1 all over 1 ohms. For I4, we see it goes from V4 to V3 all over 4. And for I5, we go from V4 to 0 all over 2. Okay, now we're going to plug all of these into here. So I1, so V1 over 10 plus I2, so V1 minus V2 over 5 equals I3, so V3 minus V1. Now next, it's 3 plus I2, so it'll be 3 plus I2, so plus V1 minus V2 over 5 equals 0. Then the next one, it'll be I3, so I3 is V3 minus V1, plus 1 equals I4, so V4 minus V3 over 4. And then I4 is V4 minus V3 over 4 plus I5 V4 over 2 equals 3. Okay? Now we're going to start simplifying these a little bit more. Okay? Actually, let me change the color of these because it's starting to look a little confusing. Alright, that looks much better. So for the first one, let's bring... Okay, so let's see what we can do. Let's bring all of this to the other side. Actually, no, I think it's better if we bring all of this to the other side instead. Okay, since there's less over here. So V3, if we bring it to the other side, that turns into minus V3, and minus V1, bring it to the other side, that turns into plus V1. So let's add all the V1s together. So we have V1 over 10. So it'll be 1 over 10, V1 over 10, plus V1 over 5. So plus V1 over 5. And then we brought this minus V1 to the other side, so it'll turn to positive V1. So it'll be 1.3 V1. Okay. Then it'll be minus V2 over 5, which is 0.2 V2. And then we brought the V3 to the other side, so it'll be minus V3, and this is equal to 0. Now the next one, okay, so V1 over 5, that's 0.2 V1, minus V2 over 5, that's minus 0.2 V2, plus 3, but let's bring the 3 to the other side, so it'll be minus 3. Okay, so now the next one, let's bring these two to the other side. So it will be, actually no, let's actually bring this to the other side here, and then bring the 1 to the other side. So it'll be minus V1, and then V3 plus V3 over 4, because it's this minus V3 over 4 here, and we brought it to the other side, it turns into plus V3 over 4. So 1 plus V3 over 4, that's 1.25 V3. And then we brought the V4 over 4 to positive V4 over 4 to the other side, so it's minus V4 over 4, which is minus 0.25 V4. And since we brought the 1 to the other side, the positive 1 to the other side, it'll be equal to minus 1. And now for the last one, okay, so this one, V4 over 4 plus V4 over 2, that's just 0.75 V4. And then minus V3 over 4, that's minus 0.25 V3. And this is equal to 3. Actually, let's swap these two together because it's going to make writing the matrix look much more easier. Okay, now we're going to do and draw a matrix. So matrix, this row will include V1, this row will include V2, this row V3, this row V4, and this will be equal to whatever they're equal to. Alright, so all the V1s, we put them here, 1.3, 0.2, minus 1, and see the fourth row here, it doesn't include a V1, so it'll just be 0. Second row, sorry, V2s, it'll be minus 0.2, minus 0.2 again, and then the third and fourth rows don't include a V2, so it'll just be 0. V3, minus 1, second row doesn't include 1, so it'll be 0, 1.25, minus 0.25, and then V4 doesn't include 1, minus 0.25, 0.75, and they're all equal to 0, which is the numbers here. This is what they're all equal to. 0, minus 3, minus 1, and 3. Okay? Now there's a lot of ways to solve for our voltage, node voltage values. We can either solve this matrix by putting into row echelon form, reduced row echelon form, or we can substitute and eliminate and stuff like that, or put them through MATLAB. And at the end, you should get the following values. V1 should equal to 12.353 volts. V2 will be 27.3529 volts. V3 will be 10.5882 volts. And V4 equals 7.5294 volts. And these are your final answers.